Thank you so much for joining us here on Idaho Today. Erica Rader is an assistant professor in the Department of Earth and Spatial Sciences at the University of Idaho. She studies landscapes and volcanoes on Earth that mimic what we might find in space, specifically on Mars. But she doesn't stop there. Erica also studies microbes that thrive under unhospitable conditions that may tell us more about potential for life on Mars. Erica, Frank, thank you so much for allowing us here in your incredible space. You have a very impressive collection here of specimens. I want to talk to you in particular about some very exciting work that you guys are doing. You not only study volcanoes on Earth, but you also have an interest in volcanoes on other planets. How does one study volcanoes that are not even on our planet?
Yeah, so the way that we're able to translate Earth volcanoes to volcanoes on other planets is by using satellite images. So we're able to take pictures of lava flows and compare the shapes and colors of lava flows on other planets back to Earth. So the shapes of the volcanoes and the shapes of the lava flows can tell us characteristics on how viscous the lava flow can be. And then the color of the lava flow itself, like all of these basalts, can tell us about the chemistry. So if it looks like a lava flow and it tastes like a lava flow on Earth, it can also look and taste like a lava flow on other planets too.
You can take a picture of a lava flow on Mars and you can see the difference in shades of this particular kind of light that's reflecting off of it. And you can say, wow, this lava flow is way darker than that lava flow. So this one probably has much more glass and therefore cooled much faster than that one, which means perhaps this one flowed into water, or maybe it was extremely cold when that volcano erupted. And that's how you get back to the climate on Mars, which is what everybody is interested in. Could it have been habitable at one point in time?
Wow, that is fascinating. Absolutely fascinating. In addition to studying volcanic flows, you guys are also studying microbes. Tell us about that.
Yeah, so that's a project that ties into Mars as well. Microbial life on Mars is probably what life would have looked like when it first started. So everyone is interested in how do microbes first find a place to live. And on Mars, much of the rock is basalt, like these here, like the material that's produced out of the volcanoes in Idaho even. And so when these volcanoes erupt, there's no life first, and suddenly it becomes habitable for microbes. We're studying how does that process happen, what about the rock makes it a nice place to live for microbes, and therefore where should we look for life on Mars or ancient life on Mars based on what the rocks look like.
How are you helping students that are place-bound in certain spots of Idaho where they might not even be able to just touch a rock, like touch some of the basalt here, right, and understand parts of the lava flow? How do you bring that education to them?
One of our classes requires 3 weeks living together outside, looking at rocks, mapping rocks, doing geology.
Very hands-on.
Very hands-on, yeah, and very personal, close with people. So we developed a online field camp to allow students to still get the activities of exploring a space and mapping a landscape without needing to be next to somebody. And this is actually very similar to how remote sensors study other planets. They don't get to be there, so they're working through this virtual reality landscape oftentimes, where they can actually walk around on the surface as people have created it digitally. So we created this class in the video game Minecraft, because Minecraft it's a landscape and you can build it up and you can dig into it, and there's different rock types. That's actually really great for...
And very popular too.
Very popular. Yeah, half the students were like, I love this, I haven't done this since I was 10. And half of them were like, I've never done this and I'm gonna fail. And they didn't, because it's a very simple game. They all did great. And it worked out really well. The students did a great job and they learned a lot of the same skills that virtual astronauts will need to learn to also interpret the landscape around them.
What do you guys love about what you do?
I got into this because I like being outside so much, but then I realized, well, what is outside? What is all this stuff around us? Like, yes, there's plants and animals, but what's below that? There's this whole planet of rock that we can't even see sometimes. And there's certain rocks that people like because they're pretty, but then there's rocks that people think are ugly. And what are those rocks? How could there be this huge thing of ugly rocks out there? And then I found basalt, which is kind of a boring rock to a lot of people. But I think it's so fascinating because it can move in so many different shapes and textures and colors.
I just like studying other planets and other worlds just inherently. When you're exploring another planet, it's like opening up a whole new story just by itself, but also geologically. You know, we only live on one planet, and there are so many more other planets out there. And how are we even going to start connecting those stories together? So by studying lava flows, I've been able to study Venus, I've been able to study the moon, Mars. By looking at our own planet and even our own climate, I can start telling other stories about other planets as well. And that's what gets me going with this.
And where can people go so they can learn not only about the research that you guys are doing here, but also the geology department here at University of Idaho?
Yeah, so they can go to idaho.edu and search for my last name, R-A-D-E-R. And a bunch of stories will come up, and you can click on any of them to find out more about our projects and the degrees that we have in our department.
Great, thank you both so much.
Thank you.